Hi, today I'll be explaining Retrieval Augmented Generation or RAG, which is at the forefront of agentic AI now. So consider the simple architecture wherein you need to query a bunch of documents. That's the basic example. So you have your AI or large language model over here. You have your user, which is you or me, asking an agentic application a query. So that is basically what happens. You ask a query and it fulfills some task for you or get some metrics. So you have a document, say you have Xbox or PlayStation troubleshooting guide. You need the perfect answer to any guide. You get those manuals in your cars that you never want to read. So you put something like that in a vector DB. How do you do that? First, you have to embed it. You have to go to chunking. You have to create chunks of relevance in the document so that these vectors, when matched with a query vector coming in, it has to produce some relevant context to the LLM. So you have fixed chunking, recursive chunking, or semantic chunking. I'll explain one of them. Semantic chunking, like chunking with context to a table, a paragraph, an image, etc. So once you have these vectors in your vector database, if they are vectors, so we can apply mathematical operation to them. They are vectors like this. You know what a vector is? Something that has both length and direction, magnitude and direction. So we perform a similarity search. So you have, let me reiterate once more, you have your user asking a query, you have your large language model, you have your agentic application. So we convert this to embeddings, the query. Then we perform a similarity search using cosine similarity, dot product similarity, Euclidean similarity on our vector database. And it should return the most similar vectors that make sense. Suppose I ask, what is the black screen of death in PS5? So after that, it has to tell me, you have to get it has to exactly know what I'm pertaining to, question here, answer here. So it will get from the document store, this is the answer. You have to follow these particular steps like download a software and put it in a pen drive and flash the whole PS5. So this has to be inputted into the LLM for the LLM to provide additional context with the context that you have provided already. So that is similarity search, and what RAG is, you just have to, it is an entire flow using a vector database to supplement the context of a large language model. Now coming to re-ranking, why is that important? In every AI search, there's some parameter called K, like you have temperature in your large language model fine tuning, which basically is a hallucination rate factor, temperature. Uh, and K refers to how many top documents have you, chunks or documents have you fetched. So mixed marginal relevance is something, it's a re-ranking algorithm that basically optimizes a document's relevance in terms of retrieval that you can look at. And another important thing is, how do you store things in the vector database? There's something called hierarchical navigable small world. It is a graph based solution wherein the upper layers are sparse and the lower layers are more dense with nodes. You might ask, you're talking about a graph now, and how does it relate to a vector DB? So each node is basically a chunk of vectors that are stored like a list, but actually it's a vector when you transpose it. So that is what hierarchical navigable small world is. This is a greedy algorithm to fetch the data. Only caveat of this is that it is memory intensive. It might take 10 million vectors, several GB to store. So that is what I want to talk about today. Thank you.